The James Webb Space Telescope has once again stunned the scientific community, this time turning its powerful gaze on a scene of celestial violence, a massive collision in the outer reaches of the solar system, where something gigantic crashed into Neptune. This moment, captured with crystal clarity in the infrared spectrum, has become one of the most striking observations of planetary dynamics ever recorded. This is not a vague flash or an ambiguous signal. Webb has recorded clear signs of disturbance in Neptune's upper atmosphere, as well as shock waves of energy and particles spreading outward, the imprints of a recent and powerful impact. Before we continue, please like and subscribe to the channel for new discoveries. The outer planets have long been known as targets for cosmic collisions, but in the case of Neptune, such events are incredibly difficult to observe. More than 4 billion kilometers from Earth, with a faint reflection of light, Neptune is a difficult target for most telescopes. But the Webb telescope, located at Lagrange point L2 with a segmented mirror and powerful infrared sensors, has changed the game. It sees through Neptune's murky methane clouds, revealing layers of activity and movement that are inaccessible to ground-based and even orbital telescopes such as Hubble. This is what allowed the discovery of signs of atmospheric disturbance, an unusually large and rapidly expanding cloud formation in the mid-latitudes, as well as a sharp spike in thermal radiation in the impact zone. These characteristics point to a significant kinetic event, something that disrupted Neptune's deep and turbulent weather systems in just a few hours. What exactly hit the planet is still being studied. However, high-resolution images and thermal data from Webb point to a massive object, possibly a stray asteroid, a body from the Kuiper Belt, or even a small icy moon destabilized by Neptune's gravitational disturbances. Whatever it was moving at tremendous speed to break through the dense upper layers of the atmosphere and leave such a large impact. The scale of the thermal burst suggests that the collision released energy comparable to thousands of nuclear explosions. The impact broke through the methane canopy and caused shock waves that Webb recorded several hours after the event. This discovery opens a new chapter in our understanding of cosmic collisions. Unlike Jupiter, which was struck by the Shoemaker-Levy 9 comet in 1994, Neptune had previously remained beyond the reach of such observations. Its remoteness and lack of a solid surface made it difficult to determine the long-term effects. But thanks to Webb's real-time observations, scientists can now study such a catastrophe as it unfolds. The data provide a unique opportunity to glimpse Neptune's atmospheric processes, how the planet absorbs, redistributes, and recovers from energetic impacts. Infrared data showed the formation of huge vortices resembling supercharged hurricanes swirling around the point of impact. These structures stretch for thousands of kilometers, transporting heat and cloud masses from the equator to the poles. Some scientists believe that such disturbances could develop into semi-permanent atmospheric formations, such as the Great Dark Spot, first recorded by Voyager 2 in 1989. Now, thanks to Webb, researchers can observe how these formations grow, interact with jet streams, and either dissipate or transition into long-lived systems. The significance of this discovery extends beyond a single planet. Observing real collisions allows astronomers to test models of planetary evolution and collision rates in the solar system. The outer planets are surrounded by icy rings, rocks, and billions of small bodies, a veritable cosmic shooting range. This collision confirms that even at the edge of the solar system, gravitational interactions remain active and potentially destructive. Neptune's mass and location make it a kind of gravitational guardian, deflecting or capturing objects that might otherwise head toward the inner planets. However, this incident shows that it is also a target, and the size of the body that caused the impact suggests that there may be many more large objects in the Kuiper Belt than previously thought. This has important implications for planetary defense. If even Neptune, a giant with a powerful gravitational field, can be struck by such a large body, the question arises, how many similar objects could one day head toward Earth? Observing the object's heat trail long after the impact also offers hope for the development of early warning systems. If we can detect the effects of collisions from billions of kilometers away, we may be able to detect threats to Earth in advance. Neptune also demonstrated remarkable resilience. Webb's observations recorded sharp changes in cloud structure. High methane clouds dispersed and then reformed, but in different patterns. Some scientists believe that the energy of the collision could have stirred up Neptune's already turbulent atmosphere, changing wind speeds and jet stream positions for weeks or months. Even the planet's magnetic field, which is already one of the most unusual in the solar system, shifted and tilted, experienced short-term disturbances. Webb's instruments recorded anomalies in the polar auroras above the planet's poles. This could mean that the impact or charged particles resulting from it temporarily disrupted the delicate balance between the magnetic field and the solar wind. If confirmed, this would be the first time a collision has affected the magnetosphere of a gas giant, an exciting discovery that could change our models of how planets interact with their environment. One of the most intriguing consequences is a renewed interest in Neptune as a research subject. The planet has long remained on the fringes of observation, beautiful, mysterious, but distant, and poorly understood. Now, thanks to Webb's clear and dynamic view, our perception of Neptune has changed. It is no longer just a blue spot at the edge of the system, but a living, breathing world with weather, collisions, and changes. Interest in Neptune's role in the architecture of the solar system has also been revived. Theories have long been put forward that it was Neptune's migration in the early history of the solar system that shaped the orbits of the Kuiper Belt objects and influenced the formation of other gas giants. Now, observing the modern collision, scientists have obtained real confirmation. Neptune is still actively interacting with its environment. The success of the James Webb Telescope in this observation highlights the enormous leap forward in humanity's capabilities. Without it, such an event might have gone completely unnoticed. But now, thanks to its infrared vision and high-precision tracking system, we can not only observe the consequences, but also track the precursors of collisions. This is a new era of observation, when the boundaries of what we can see are rapidly expanding. While the analysis of the images continues, scientists are reconstructing the object's trajectory. Preliminary calculations indicate that it originated from the scattered disk, an area beyond the Kuiper Belt, where icy bodies move in eccentric and inclined orbits. If confirmed, this would reinforce the hypothesis that Neptune serves as a gravitational gateway, occasionally pulling ancient wandering bodies from the outer reaches of the system. Each such collision is not only destruction, but also a trace, an artifact of the chaotic past of the solar system. The chemical signatures of the impact are particularly interesting. Webb's spectroscopes detected bursts of hydrogen cyanide, ethane, and acetylene, molecules that can form under extreme pressures and temperatures. These compounds, briefly illuminated by infrared afterglow, indicate either exotic ices brought by the object or chemical reactions caused within Neptune's atmosphere. In any case, the data obtained is a real find for chemists and planetary scientists. If you liked this video, please like and subscribe to the channel. Leave a comment. What do you think about the massive collision with Neptune? What could it mean? Thanks for watching, and see you next time.